Let's solve this geometry puzzle carefully. We have two towers facing each other. The tower on the left has a height of 12 meters, and the tower on the right has a height of 4 meters. A cable is drawn from the top of the 12-meter tower down to the base of the 4-meter tower, and another cable is drawn from the base of the 12-meter tower up to the top of the 4-meter tower. These two cables intersect exactly at the top of a person's head, and our goal is to find that person's height. Let's call the person's height K. We'll also let the horizontal distance from the left tower to the person be P, and the horizontal distance from the person to the right tower be Q. Now, let's focus on the cable that rises from the left base to the top of the 4-meter tower. Notice that the small triangle formed near the person and the large triangle formed by the entire cable are similar triangles. The reason they are similar is that they both contain a right angle, and they share another corresponding angle along the same line. When triangles are similar, corresponding side lengths are proportional. Therefore, we can write P divided by K equals the quantity P plus Q divided by 4. Let's keep that equation. Next, let's look at the other cable, the one that slopes downward from the top of the 12-meter tower to the right base. Once again, we have a small triangle and a larger triangle that are similar for exactly the same reason. Corresponding sides must be proportional, so we obtain Q divided by K equals the quantity, P plus Q divided by 12. Now, we have two useful equations. Let's add them together. On the left-hand side, we have P divided by K plus Q divided by K. Since both fractions have the same denominator K, we can combine them into a single fraction. That gives us the quantity P plus Q divided by K. On the right-hand side, we simply add the fractions, giving the quantity P plus Q divided by 4 plus the quantity P plus Q divided by 12. So our new equation becomes the quantity P plus Q divided by K equals the quantity P plus Q divided by 4 plus the quantity P plus Q divided by 12. Notice something important here. Every term contains the common factor, P plus Q. Since P plus Q is non-zero, we can divide the entire equation by P plus Q. This cancels that factor from every term and leaves us 1 divided by K equals 1 divided by 4 plus 1 divided by 12. Now, let's add the fractions on the right-hand side. To do that, we need a common denominator. The least common denominator of 4 and 12 is 12. So 1 divided by 4 becomes 3 divided by 12. And 1 divided by 12 stays 1 divided by 12. Therefore, 1 divided by K equals 3 divided by 12, plus 1 divided by 12. Adding the numerators gives us 4 divided by 12. Then we simplify 4 divided by 12 by dividing the numerator and denominator by 4, giving 1 divided by 3. So now we have 1 divided by K equals 1 divided by 3. To isolate K, we take the reciprocal of both sides. The reciprocal of 1 divided by K is K, and the reciprocal of 1 divided by 3 is 3. Therefore, K equals 3. That means the height of the person is 3 meters. Notice that throughout the entire solution, the actual horizontal distances, P and Q, never needed to be calculated. They canceled out naturally during the algebra. The intersection height depends only on the heights of the two towers, which is a very elegant result. So the final answer is 3 meters. If you found this solution helpful and enjoyed seeing how similar triangles can make a seemingly difficult problem surprisingly simple? Be sure to like the video, subscribe to the channel, and leave a comment with your answer before watching the solution.